Hi and welcome to today's lecture about embedded systems and e-health applications. My name is Arthur Schuchter and I'm here from the University of Tromsø. Well, I'm sitting in Bodø and I'd like to provide you with a short introduction about embedded systems as well as how you get started with the BeagleBone Black, like the single board computer we are using here right at the University of Tromsø. Our main focus is on embedded systems, especially on e-health applications. And what is very important for you, the elevation of the whole course is divided into two parts. The first part is 80% of the whole course is a project where you can work together in a team, where you two or three people, and you try to create an application where you use the BeagleBone Black and other kinds of components. The other 20% is active participation, which means answering questions and quizzes, which are most of the time at the very end at every presentation. So try to find all the information in Canvas and answer the questions, respond to them, and try to contact me if you have any problems. We here in Bode are a team of 3 teachers consisting of Øyvind Tuve, Axel Transet, and myself, Arthur Schuchter. If you have any questions, as I said before, whatsoever, don't hesitate to contact me over email, or you can even contact me over Facebook. It's really no problem. So let's get started. What are embedded systems? Here we go. Embedded systems, well, there are many people talking about embedded systems, but what are embedded systems? An embedded system is a programmed system with a special function, combining different various devices working together or talking together, communicating together, with most of the time having a special focus on a global or special output. Most of the time, real time or low power consumption or low cost is a very important constraint if you're talking about embedded systems. Embedded means it is a part of a complete device, often including hardware and mechanical parts. Embedded systems also means controls and devices work together in a team, so which is very important to us. Teamwork is very important, not only in this at university, it's also very important for us as an embedded system. Nowadays, when you see all the research, 90 to 80% of all the microprocessors are manufactured as components of embedded systems, which are quite a lot. If you think about very important and well-known applications where embedded systems are used, it's most of the times everybody knows cars and smartphones and surveillance cameras, and there are a huge amount of different kinds of embedded systems. Examples of properties of typical embedded systems or embedded computers when compared with general purpose counterparts are most of the time low power consumption, small size, low cost, of course, and as I said before, real time. So becoming real time or getting real time is a very important aspect of embedded systems. This comes often as a price of limited processing resources, which makes it very important to interact or how to improve the interaction between all the important parts. So here we go. When you talk about embedded systems, there are very important components which we have to talk about. And there are two very important pin layouts, are two important ports which are very used in many occasions. And this is the first is the GPIO, which means General Purpose Input Output System. The General Purpose Input Output System is a very important part, which is a pin where you can decide as a programmer whether this pin is used as an input or an output, as well as you can deprogram it for many different occasions, especially often used in multimedia applications. Another very important port is the Universal Asynchronous Receiver Transmitter, or shortly UART. The UART has a transmission engine which you can program as well. And in many occasions you have to handle different data, so it is very important to decide how to transfer them or receive them. So the UART helps you, and you can handle data in different kinds of ways. So for instance, you have video, audio or text. You can't transmit them in different data rates, which makes it very powerful tool to use for us. So you will soon get used to the UART and the GPIO, but never forget those two components, which are very important aspects for us. When we deal with eHealth applications, we have to deal with the state of the art and the state of the art problems we have right now. And so let's see, here we go. The problems right now of eHealth applications are quite a lot. Right now we have to face different problems, and more problems arise because more and more embedded systems arise. So because of the huge amount of data, many problems, we have to deal with the data, and we have to sort, we have to transfer them, we have also to find ways to talk together with the data and to use the data. So because of the huge amount of the data, it is nearly impossible to handle the data in other ways. Another problems are getting, for instance, real time. So real time is very important, because what's the use of a surveillance system if the criminal is detected 2 minutes afterwards? So for instance, if you have systems, and in many occasions the system has to be real time to be useful, especially when you're talking about streaming and video conferences. So you have to deal with such problems, and we have to optimize memory allocations as well as transfers and communication systems between all our devices from our embedded system to enhance the possibilities of such applications. So most eHealth applications nowadays have such problems, and we have to find ways, for instance parallel computing or better communications between them, to find ways of all the improving and the optimization of our complete system. So when we talk about eHealth applications, we mostly see different ways of sensors. So we have many different ways how sensors compute, how sensors process and how sensors work together as a team in our embedded systems. And as you can see in this graph, you have many different sensors where you can work together as a team. And another aspect is you always see internet. So because you want to distribute, and you also want to provide other people with the data you collected, so internet is very important and becoming more and more essential in embedded systems as a whole. So you have to take into consideration what is important and what's not. We will give you in some weeks more and more detailed information about sensors and how sensors work together in embedded systems with us. So we have to find ways what's important for us. So why we have chosen the BeagleBone Black? The BeagleBone Black is a very powerful tool. When we talk about the BeagleBone Black, we can find different ways of microprocessors or single board computers, and most of the people know like Arduino or Raspberry Pi. So the first question arises, why did we choose the BeagleBone Black? If we compare the BeagleBone Black to Arduino or the Raspberry Pi, it is very important to know that the Arduino is very limited. And as you can see in the lecture notes as well, Arduino is a very nice tool to begin with, but all the possibilities and all the ways you can want to improve applications, the Arduino is very limited. So the BeagleBone Black gives you more and more possibilities to build your own applications. The processing power of a Raspberry Pi, on the other hand, is very good. But still, if you want to program all your applications by yourself, it is very hard to find ways to really come into and enter and plunge into the system and provide and program your own applications. So it's sometimes very hard to find ways. So we here find and focus on the BeagleBone Black and the BeagleBone, all the Beagle boards and all the stuff which is coming to it, because you have possibilities. You can decide whether you're more like a web person and program in JavaScript or PHP or Python or C++. So it doesn't matter actually which kind of programming language you want to choose. And as well, when working together with sensors, the BeagleBone Black gives you a very huge amount of possibilities where you can build your own applications easily. But all the special components of the BeagleBone Black will be dealt in the next video lecture. So thanks for today and have a nice day. Bye.